Hello class, so today we'll be going over how we create our flow graph in our FFT. Alright, so in this case we're going to be making a flow graph using a 2-point, so our K here will be equal to 2. In this case should be green, my bad, I'll go back and won't mention that later. So our two values on our unit circle for our 2 point is going to be 1 for our real and -1. So we're only having real components in 2 points. And I'm just going to try to mark something down real quick. If I find a color I haven't used before, we'll do brown. So in our previous video where we went over how to draw an FFT equation, you saw our unit circle was with a 4-point, having these particular 4 points that I just marked in brown. But in our case, for this video, it's going to be 2 points, which will only be this one here and that one there, with values of 1 and -1. So we won't have any imaginary components. So in our total factors, W0 of 2 and 1 of 2 will be equal to 1 and -1, as I marked down over here on the side in green. And for some more information on different total factors, we have a video you can look into. But let's move on over here, and I'll show you how to go from our equations over to a flow graph. And this is for 2 points, so we're going to write down our 2 samples, x is 0, x is 1. We'll want to find our DFT or FFT outputs being f of 0 and f of 1. So first thing we did is we went down, we wrote 2 straight line markings, and we got to connect them looking back to our formulas. And the way you do this, you're going to want to work backwards. So here, our f of 0 is going to be equal to our x of 0 multiplied by 1 added by our x of 1 multiplied by a total factor W0 of 2. And the same would be for our f of 1. It's going to be our x of 1 multiplied by 1 added over to our x of 0 multiplied by, if I can get these little arrows in to show they only flow in one direction. You can't go backwards. Sorry guys, I just can't seem to get this little total factor written in here very nice. Just zoom in and I'll try to write them in a little better for you. So that'll be our x of 0 of 2 and x of 1 of 2, because we're trying to find our 0th sample and our 1th sample, if you want to say it like that. Alrighty, so let's go ahead and work out an example. So let's say our x of 0, we'll assign it a value of 1, and our x of 1 value is going to be equal to 2. Dun, 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 dun. Let's see. So our first value we're going to try to find will be our f of 0. If we look up at our flow graph, and you can even look back to our actual equations, f of 0 is equal to our x of 0 plus the total factor W0 of 2 multiplied by x of 1. So here our x of 1 is equal to 1 plus our total factor, which is 0 of 2. You can look back to our unit circle and see that we defined our W0 of 2 to be a value of 1 with no imaginary component. Then we're going to also multiply that by our x of 1 right there. And I think a little sock just came out and told me I made a little mistake here. That guy should be 1. Yeah, 1. Sounds good. So this value over here is 2. And from this point, it's pretty simple algebra. multiply it out and add it up, and we'll end up with f of 0 equaling a value of 3. So let's go ahead and write an equation for our FFT sample of 1. It's going to be equal to, we'll zoom back over here for consistency with our first example. It's going to be equal to our x of 1 multiplied by our x of 0 with a total factor. Our x of 1 has a value 2, our total factor, w1 of 2, was negative 1, because it's the complex conjugate. That won't always be the case, but in this case it is. And our value x of 0 is 1. And again, another algebraic step. We'll go through and multiply these out. We end up with the value of 1 in the end. We'll see you back for another video, and we'll go over 4-point DFT.